안녕하십니까?
Hello, I am Dr. Chun Se-young. I'm with the Hyundoa Good Morning Dental Office. This is the second lecture of Digital Dentistry, and this time I'm going to talk about the understanding of fully guided implant. Full guide implant, what is it? First, the full guide implant. It is characterized by the top-down implant planning. The conventional approach is the fixture is placed and abutment and crown are fabricated afterwards. However, the fully guided implant means crown shape and the position are determined first, and after that, and the fixture position is made. So this is a top-down implant planning approach. First, teeth are extracted. Second, crown is designed like in the picture in the extraction socket. So a crown is designed in an accurate position between the adjacent tooth and opposing tooth. CT data, which is 3D data, and oral scan data are utilized, and the two data are merged together. The common factor between those two are the teeth, so the teeth are the landmarks to merge the two data sets. In this situation, we design the implants. The accuracy of the merged data should be checked, as in the picture, by confirming how they are matching with the green teeth before moving on to the next step. Then, a very precise full guided implant surgery can be done. The designed crown and gingiva, alveolar bone, nerve, opposing teeth, and all other data are displayed like this on the virtual world. In this condition, crown, gingiva, bone, nerve are considered to design the optimal positions for implants. As you can see, figures and the heights are measured, considering abutment shape and gingiva shape that we want. If they can be reproduced given the figures and heights in terms of the length and width to determine implant positions, final decisions including prosthesis is made by measuring these lengths during the planning process. For relations with adjacent teeth, the height of gingiva of the adjacent teeth from fixture top to the contact point, the extension of vertical and horizontal volume are considered to check if abutments can be fabricated or physiologically ideal forms can be made when implant fixture positioning is done. Such decisions are made during the planning. Next, once the fixture positions are determined, the guide is designed and it is printed using a 3D printer. In the fully guided implant, once implant fixture positions are determined, based on that fixtures, prosthesis can be prefabricated, as it is possible to place the fixtures later in patients. The prefabricated prosthesis will be set with good fitting. I will show you the process. First, in an implant planning software such as Implant Studio, the guide and the fixture positions are decided. From there, CT data and the oral scan data and the fixture coordinates and fixture positions, the three will be combined in 3OZ file, and the file is uploaded to a CAD software for prosthesis. With the prosthesis software, based on the fixture positions, abutment and crown prosthesis can be designed. The designed abutment and the prosthesis will be in the STL file, which will be sent to the CNC or 3D printer to fabricate the prosthesis or abutments before surgery. Here, briefly, let me explain or introduce a three-shape digital solution. Three-shape digital solution includes Trios 3, which is Trios 4 now, the oral scanner, which is the most precise one, prosthesis CAD software, dental manager, and ortho software implant studio. It is equipped with the full line of dental CAD software, the top-notch level around the world. Pre-OP workflow. At the beginning, data is collected using oral scanner. Scan data is acquired, and the three-dimensional data is acquired using the CT. Next, with the design planning software, fixture coordinates are determined and further designed in the prosthesis CAD. That is the design stage. Next, the designs are fabricated using 3D printers or CNC milling machine. That's the production manufacturing stage. Before surgery, guide, abutment, prostheses are prepared. So this is the final preparation stage before surgery. 3D digital implant, a fully guided implant. Let's look at the characteristics of that. 3D digital implant. It is also called the fully guided implant. It is different from conventional approach. Three-dimensional data is used for the planning using CT data or scanning data. Conventionally, we use the X-ray films or model to do the design and planning, but now we look at actual forms of a patient in an intuitive way while planning. That can be the biggest advantage. So I said before, a fixture placement is considered very important, but we use the top-down approach in the work sequence, so crown is determined first, and it is designed first before we determine the optimal fixture positions by considering bone, gingiva, and other structures. As I said before, CT, intraoral scans are accurately merged. All data, including soft tissue and hard tissue, are merged to design the prosthesis. Based on such precise merging technology, planning simulation is done. Next, using the well-planned implant positions to place implants precisely in a patient, precise guide and drill system should be very precise as well. Such precise system is required. And lastly, as I explained before implant is placed in a patient, pre-designed data is used to prefabricate prosthesis, temporary or abutment to do immediate placement. Osstem's one guided system is a wonderful, full guided system. I can say that with confidence. For the full guided design, I have used for the precise guide all the guides with a sleeve or sleeveless guides. This is a guide with a sleeve that I used in a hospital before. It was printed and adjusted. If you look at the metal sleeve and the guide resin portion, as you can see, the gaps and offsets of each hole is different. That means a 3D printer has a pretty high level of errors. From the bottom of the same sleeve hole, it cannot be fitted. I realized from this that there is another level of errors between the guide and the sleeve. High speed versus low speed. The first one, with one guide system, drilling without a sleeve, the inside wall of the sleeve is cut, then the fixture design can be different from the designed positions. That's the disadvantage. The second image of drilling, it is an example of low-speed drilling. Through the drill tube, it is driven at a low speed. If you look at this image, what I realize is that when there is no sleeve, when the drilling is done at a low speed, if you look at the inside wall of the hole, compared to the high-speed drilling, this is more stable and no distortion is made in this case. So, when a guide sleeve is not used, low-speed drilling is more accurate than the high-speed drilling. That's what I've been thinking about for a long time. So, if you use low-speed drilling, the gap between the barrel and the sleeve can be minimized, enabling more precise drilling. That is the advantage. In this case, high-speed drilling, just like one guide drilling, when we do not use a sleeve, the same problem occurs. The inside wall can be cut away and distorted more than at a low speed. So in a guided surgery, let me talk about the top secret solution. What I'm proposing is that sleeveless guide plus low-speed drilling. This solution can render most accurate solution. That's what I want to say. During the implant planning, this can be very helpful as well. In this patient, we plan to place 4 implants, and the surgery was planned. And during the simulation, as you can see, the implants are positioned at each tooth place, and there's interference between them. Therefore, they were corrected to be in parallel with each other. Number 24 fixture is interfering with the root of canine in this simulation. So next, everything is inclined distally. For implant placement is okay, and the prosthesis is okay as well. But among the prosthesis, abutment, and the fixture, the relation is not physiologically stable. Therefore, I boldly decided to remove number 24 implant using the 3 implants. The prosthesis with the cantilever bridge is designed, and I decided this would be the ideal, the optimal implant design. For the sinus lifting, as you can see, on the left picture, 360 fixture rotation is used to position the fixture accurately. The yellow line is the imagined future gingival line to have a more optimal crown shape. The red line is the future GBR height. Fitting that, the angle and length of a fixture can be determined before surgery. Horizontal augmentation, GBR case. In this case, the buccal bone of number 46 is severely resorbed. In this patient, there's no problem to do implant placement and prosthesis without bone graft. However, if you look at the gingiva, if the gingiva can be made like this, more ideal and physiologically stable placement can be done. In order to raise gingiva up to this level, GBR is planned. So the gingiva will be raised superiorly and buccally. Then this much bone graft is needed. If you look at actual thickness of the gingiva before bone grafting, it is pretty good. If we need this much gingiva thickness, not only the bone graft but also soft tissue graft is needed. At this stage, the diagnosis and the planning have been made. Therefore, bone graft and soft tissue graft was done. This is the contour of definitive prosthesis, naturally flowing with the gingiva like a natural tooth to facilitate the self-cleaning as much as possible. And this is how it is finished. Before surgery, all of these were planned before surgery using the implant studio. Here, the full guided implant is compared to the analog implant. What are the differences? In the past, focusing on bone, implants were placed, so the definitive prosthesis do not fit the fixtures like this. Actually, this was considered very good prosthesis work. However, if you use the full guided system like Implant Studio, as you can see here, abutment holes and positions fit pretty well with the definitive prosthesis, enabling the ideal prosthesis. That is the difference between the full guided implant versus analog implant. In the anterior region, abutments are placed between teeth, and there was difficulties in the lab work to overcome that problem. But using the Implant Studio, in advance, using the top-down approach, the design and the fixture positions are designed, then the problem can be minimized. More aesthetic and a natural tooth-like appearance can be achieved, and the relation between the prosthesis and gingiva looks very natural. In this patient, I placed the implant and I thought I did a good job. On the left, the fixture position, if it was 2 millimeters more anterior, it would have been much better, but I thought I did a good job. In this implant, as you can see indicated by the arrow, tooth cleaning, infection control, or bacteria control is a little bit challenging with that undercut. Over time, bone resorption occurred that can be seen from time to time. This is inevitable because the fixture position is a little bit distal and the occlusal force is applied anterior to the fixture. Therefore, the torque is applied to the connection part. This is the implant I placed myself. I regret that there should be more gap between the fixture and the adjacent tooth. However, with the guided surgery, as you can see in a very narrow space, a very appropriate implant position can be made with the proper prosthesis. That's the characteristics of the full guided surgery. In the past, the implants were placed in another dental office, and the patient came to my office. I believe that the original bone height was like this. the patient said they were placed a long time ago. The abutment is designed like this, very long. Currently, the bone is resorbed to this level. In my opinion, the abutment is quite long. In these cases, it is not very good for self-cleaning and tooth cleaning. Therefore, the bone is resorbed quite severely. On the opposing side, the implants were placed in the same dental office. Number 7, the abutment is very long. Therefore, this is a case where peri-implantitis was bound to happen. That's what I thought. So, for the anterior region implants, I try to make the bone level as much as in line with the adjacent teeth with the bone grafting. In the alignment, if I try to align them just manually, I don't believe the bone level that I desired could have been achieved. So with the guided surgery, the angles and positions of implants were made as planned. As a result, prosthesis like this was achieved. Let's look at the full guided surgery's advantages. The full guided surgery utilizes a three-dimensional anatomical structure. That is the biggest advantage. Patient body is three-dimensional, therefore, with a three-dimensional structure, so the surgery can be done in an intuitive way, fitting the real situation. So using the three-dimensional anatomical structure is a big advantage. The implant fixture can be designed in a safe place, in a safe positions. And on the computer program, a three-dimensional simulation has been done to address predictable problems during surgery, and preparation can be done for such eventuality. So when we actually do the surgery on a patient, we can conduct the surgery in a shortest possible time using the shortcut, giving least trauma to the patient. I mentioned the top-down fashion several times. In designing the prosthesis in a more realistic situation, ideal positioning can be done. So, unexpected dilemma we can experience during prosthesis stage can be avoided. As I explained before, vertical and horizontal factors are considered during the design. I showed you a soft tissue management case. Integration between prosthesis and soft tissue can be made better. The prosthesis longevity can be ensured, and we can provide the environment where peri-implantitis can be prevented in advance. That's the advantages. Q&A. So let's look at some questions. Low-speed drilling and sleeveless guide protocol. Is there any objective evidences for that? The protocol actually doesn't have objective evidence. I have done the guided surgery for the last 5 to 6 years. I used various approaches, low-speed or high-speed drillings, and I've experienced advantages of one over the other. I have used a guide with a sleeve and without a sleeve. So the statement I made about this is based on my personal experience. It is not objective. The reason why I introduced this approach is that not only me, but other doctors will achieve more accurate surgery. Using this, that's the intention of my introducing this approach. Next, what should be the things we need to consider for immediate placement after extraction? This is one of the most challenging guided surgeries because there's irregular extraction sockets. We do the drilling through the guide, but when we do the drilling, depending on the shape, like a concave wall of the extraction socket, the drill can slip. In that case, bone flattening drill can be used, or to prevent the slipping of the drill, you can apply force to the opposite direction, or you can use a path drill from Osstem. The drill doesn't slip as it is designed that way, so that the drill direction is as planned, should not deviate from the plan. That's the most important thing when you do the immediate placement. Right after the extraction, during immediate placement, if I feel the drill is slipping rather much, then I switch the low speed to high speed with irrigation. So I use the high-speed drilling. One more thing, when we expand the drill hole, I try to expand the hole as wide as the fixture so that when a fixture is placed, it cannot slip, the drill cannot slip to the other direction, even though the initial stability may become low. The third question, can guided surgery be used for all implant cases? Just to say yes or no, they can be controversial, but based on my clinical cases, I showed you the soft tissue management case, also sinus lifting design. Soft tissue can be designed as well. So the guided surgery simulation is used for all those, and the guide systems and the drill systems are available to do all the planning and actual surgery as planned. Therefore, I believe the guided surgery can be used in simple or very complicated cases to make the cases more complete. Guided surgery system can be used for all such cases. I can say that with my confidence. The digital dentistry second lecture, fully guided surgery, has been discussed. Thank you for your listening.
감사합니다.